So I am on volume 3, section 2.5. This will be the last one that I do for, I guess, technically chapter 2. I'm going to sum up this chapter by doing question 267. And this question is asking for the following exercise: point P and vector n are given. Find the scalar equation of the plane that passes through P and has normal vector n, and also find the general form of the equation of the plane that passes through P and has normal vector n. So I actually did start writing this out already, and I messed up my video because someone called and it messed it up. Like, it just messed up and I forgot where I was. So I have already written down P, which is 0, 0, 0, and then the vector n equals 3i minus 2j plus 4k. The next thing I did was I wrote down the standard form of like what a vector is, like bar, like n bar equals a, b, c, which is just the components. And then finally, what I did next after that was I wrote out the form of the vector, which would be a times parentheses x minus x sub 0 plus b parentheses y minus y sub 0 plus c parentheses z minus z sub 0, and I set that equal to 0 because that is what the equation is. The next thing I did was I wrote out what the general form of just the vector is, and that was in the chapter actually. And that form is just ax plus by plus cz equals 0. And I did see in the chapter that there's a plus d term. I think that's just like the constant, like adding a plus c to like an integral. So I did write plus d as well. And instead of having that all equal to 0, I just set it equal to d. So in case we needed to find d, it would just be easy. So I guess the final equation I came to for like just the basic general form that we're going to be working with before we plug in these values is just d equals negative ax minus by minus cz. Okay, and then I also continued on and I wrote down what the x sub 0, y sub 0, and z sub 0 points are, and that's actually given to us in the question. Like, it gives us that p equals, it tells us the point is p 0, 0, 0, so x sub 0, y sub 0, and z sub 0 would all just be 0, 0, 0. And since now we're trying to find the coefficients in the equation, the a, b, and c, we can look at our original vector that was given to us, the 3i minus 2j plus 4k. And all you have to do there is assign the coefficients in front of I, j, and k to a, b, and c. So in this case, a, b, and c would be 3, negative 2, and 4. So the next part is just plugging and chugging. You have the values for the equation now. So it would be 3 x minus 3 times parentheses x minus 0 minus 2 times parentheses y minus 0 plus 4 times parentheses z minus 0, and you set all of that equal to 0. And again, since it's just minus 0, it is pretty easy to distribute the coefficients, and you just arrive at 3x minus 2y plus 4z. And if you remember earlier, we had that equation set to d because we wanted to see if there was a remaining constant. And if we set that all of that equal to d, then plug in the values 0, 0, 0, because that's the point, you just get d equals 0. So the original function, the equation is just the function that we just stated, the 3x minus 2y plus 4z. And since there is no d value, I believe both the scalar and general equation is just 3x minus 2y plus 4z equal to 0, I believe. Yeah. And yep, that's my final answer at the bottom. And yeah, that is pretty much my work for volume 3, chapter subsection 2.5. So yeah, thank you.